Welcome to Parthivo Physics. So today we'll be discussing chapter units and measurement, and today is the first lesson. In this chapter, if we see the CBSE syllabus, if we see the West Bengal syllabus, almost the syllabus remain the same, and I have given the CBSE syllabus here. So what we have here, need of for measurement, under need of measurement, units of measurement, system of unit, SI unit, fundamental units, derived units, again significant figures, determining the uncertainty in the result, dimension of physical quantities, dimensional analysis and its application. We'll be learning all these things. So today we'll be mostly learning the need for measurement part, and next in the next class we'll be learning significant figure, also dimension of physical quantities. All those things we'll be learning in the next class. So before we start about the need for measurement, let us talk about something about physics. So physics is the branch of science that deals with study of nature and the properties of matter and energy. The subject matter for physics includes heat, light, sound, electricity, magnetism and structure of atoms. For this, for designing a law of physics, a scientific method is followed. Now you can ask me what is a scientific method. Mostly if you see the curiosity book of class 6, there is a chapter in the first chapter the scientific method is explained very clearly. What it said about, whenever we see something we become curious about that. So first we observe, then we think. Why we started to think after observing something? Because of our curiosity. After thinking we ask question, why that is happening, what may be the cause, all those things. There are various types of questions that can be asked. After that we create our own hypothesis. We try to solve those problems on our own, or we guess maybe that happened, maybe this happened, that's why this is happening. And here is the thing, scientific method always depend on logical explanation. So if we think something, that may be true, may be false. So how can we know whatever we are thinking that is true or is it a false? So in scientific method, after reaching some hypothesis, after reaching some guessing, we do experiment. So what are the steps followed in scientific method? First observe, then thinking, then ask questioning, then do some hypothesis, and then experiment to check our hypothesis, whether our hypothesis is true or false. After doing experiment on our hypothesis, we will be getting some result. After getting the result, we will be analyzing those results, and what answer we will get from those results? Either our hypothesis is true or either our hypothesis is wrong. So now we get a logical base for our hypothesis. If our hypothesis is true, then it is proven in experiment. If our hypothesis is wrong, it also be proven through the experiment, and from there we can get an conclusion, and that's scientific method work. So here for designing a law of physics, we also follow scientific method, which includes the verification with the experiment. In physics, attempts are made to measure the quantities with the best accuracy. Thus, physics can also be defined as a science of measurement. Applied physics is the application of physics to help human beings solve their problem. It is usually considered as a bridge or a connection between the physics and engineering. So if I talk about engineering is nothing but a branch of physics known as applied physics. Now let us come to physical quantity. What is a physical quantity? Actually, all quantities in terms of which law of physics can be expressed and which can be measured are called physical quantity. Now, what do we mean by which can be measured? Measurement, we can express that thing with certain number. And also, in case of physical quantity, two things is important. One is number, magnitude, another is unit. Okay. So let us say we have a two number. Is there any difference between these two number? There is no difference. Now I am saying that the unit of this number is kg, unit of this number is kilometer. Now can we compare these two 5 or can we take these two 5 as equal? The answer is no. We never able to compare a mass with a distance. So number is very important, also as well as units is very important here. So unit define that thing will be coming, why the unit we need will be coming that later. So let us come to the thing that we have here, physical quantity. So physical quantity, all quantities in terms of which law of physics can be expressed and which can be measured are called physical quantity. For example, distance, speed, mass, force, etc. Now measurement, in our daily life we need express or compare the magnitude of different quantities. This can be done only by measuring them. And measurement is the comparison of an unknown physical quantity with a known fixed physical quantity. So comparison, if I say A is, let us say there are two people are standing here. I am saying that this person is A and there is another person. Okay, this person is B, there is another person C. Okay, now I am saying that A is all of them are standing together, and I am saying that A is taller than B, again C is taller than A. Okay, now this is the height of them. Okay, and but their height is very near to each other. Let us say one is 150 centimeter, another is 151 centimeter, another is 150 55 centimeter. Okay, like that they are standing together, so we can more or less guess that the height. Now who is taller, who is shorter, we can guess that. Now let us say they are standing in different place. Let us say one is standing at field, another is standing in your room, another person is standing in classroom. Now you have seen all of them, but to you, who is taller, if you don't know the height, you can't, if you don't see them together before, you can't guess that, because all of their height almost equal, right? So by giving them certain number, by measuring the number, their exact height, that is 152 centimeter, 151 centimeter, 155 centimeter, by using this number we can easily compare their height. How much taller is C? How much shorter is B? We can easily compare them by using this magnitude of number. That's why in measurement, number is very, very important. Now, before I have also said that why unit is very important. So the known fixed physical quantity, actually whenever we are talking about 5 kilometer or meter, we use a single unit, 1 kilometer, with respect to it how much times the distance is, that is measured. Let us say this is 5 kilometer, 1 kilometer, 2 kilometer, 3 kilometer, 4 kilometer, 5 kilometer. This distance is 1 kilometer. Okay, this distance is, so 5 kilometer means 5 times of 1 kilometer. Now how we define unit? See here, the known fixed physical quantity is called unit. The quantity used as a standard for measurement is called unit. Normally there are certain method, certain system of units are there: CGS unit, FPS unit, MKS unit, SI unit. In all those units there are certain length, certain mass, certain um, time is taken as a unit. Okay. There is an example given. For example, when we say that the length of the classroom is 8 meter, we compare the length of the classroom with standard quantity of length called meter. Okay. Now length of the classroom is 8 meter. Q is equal to nu. Physical where physical quantity is equal to numerical value into unit. Now Q is equal to physical quantity, N is equal to numerical value, and U is equal to standard unit. So length is the length is the physical quantity. Okay, physical quantity, and numerical value here 8 is the numerical value. And meter is the unit. Okay, and why is unit important? As I have said that, let us say we have two number 5. Okay, now if I say is there any difference between these two number, the answer is no. If I say 5 is kilometer, 5 is kg, now if I ask is there any difference, what will be our answer? Our answer will be yes, there is a difference. What is that difference? One is describing a length, another one describing mass. Okay, can you compare these two things? The answer is no. We never compare length with mass. Again, if I say we have 5 kilometer and 50 kilometer, can we compare them now? Or we have a 5,000 meter. Can you compare this 5,000 meter and 5 kilometer? The answer is yes, because they are the unit of same thing, that is length. So depending on unit, we can compare them. Depending on unit, whether it describe a certain physical quantity. So every physical quantity has a certain units. In CGS, there are actually, before we go to CGS MKS, you should know about fundamental units. Let us talk about certain fundamental units. Fundamental units, what are the fundamental units? The quantity that is independent of other physical quantity, like length, mass, time. Okay. At the beginning of science, development of science, these three considered as a fundamental unit. All the other unit are coming from these three unit. In mechanics, mass, length, time are called fundamental quantities, and unit of these fundamental physical quantities are called fundamental units. Later we have developed, with the development of science, we have seen that with these three fundamental units, fundamental quantities, we can't able to describe all the thing that has been discovered later here. Okay, so that's why around mid 20th century, scientists of all of the world have decided to introduce a new system of unit known as SI. Okay, or it also known as you can say that Systema International. It's a French word actually. Okay, let us come back to the thing that we have. So now at the beginning we have three fundamental units: mass, length, time. In CGS unit of mass is gram, length centimeter, and time is second. Time is always second. Okay, it doesn't matter what types of units, system of unit we are taking, it always give us second. In FPS, what is it? Foot, sorry, pound, poundal, foot, and second. In MKS it is kg, meter, second. Okay, and in SI method the system is improved to extended version of the MKS method, and it is called, what it called international system. Actually the word is system international, and from there we get the SI, and the English meaning of that is international system of unit. Now before we go to the fundamental, we have already learned about fundamental units. So if we talk about classification in unit, so unit can be divided into two things. One is fundamental unit, another is derived unit. We have already talked about fundamental unit. What is derived unit? Mostly those physical quantity that depend on fundamental physical quantity are known as derived physical quantity, and the units of the derived physical quantity are known as derived units. Now how a unit what are the characteristics a standard unit should have? Okay, normally a unit is selected for measuring physical quantity should have the property, it should be well defined, it should be well defined, its concept should be clear, it should not change with the change in physical condition like temperature, pressure, stress, etc. It should be suitable in size, neither too large nor too small. Okay, let us say we are taking an unit so small that we normally we can't able to recognize that thing, we can able to see that thing, or we are taking the size is so big that we are that is going out of our sight. Like if I take the earth as a unit, radius of earth as a unit, can you imagine that length? No. Or if I take the radius of an atom as a fundamental as a standard unit, can you able to see that thing? No. So whatever thing that will be taking, that will be not very small, not too large, neither too large nor too small. It should not change with place or time, and it should be reproducible, it should be internationally accepted. Okay, now we have already talked about fundamental units. With the development of science and technology, fundamental units, these three fundamental units are not able to express all the thing that physics had discovered. Okay, now what we have done, we have taken the original MKS system and added another 4 fundamental quantities with it and 2 supplementary fundamental quantity. Okay, and what are those? First is temperature. We have added temperature as a fundamental unit in SI method, electric current as a fundamental quantity, luminous intensity, and amount of substance. And what is the fundamental units of temperature? That is Kelvin. Okay, and fundamental unit of electric current, ampere, luminous intensity, candela, and amount of substance is mole, and their symbol is given here, K A for ampere, CD small cd for candela, and mol small mole for amount of substance or mole. Okay, and what are the 2 supplementary fundamental quantities? That is plane angle, this is in 2D, and solid angle, this is in 3D, and their unit is, for plane angle it is radian or rad, and for solid angle it is steradian or SR. also know that solid angle normally represented by omega, just like the unit of resistance, ohm. Okay, so there is a question: is ohm a fundamental quantity or a derived quantity? Try to find it out. So we are talking about derived units. So derived unit, those physical quantity that are derived from fundamental quantities are called derived quantity, and their unit are called derived units. For example, aspect, for example, speed, force, work, energy, area, etc. Let us say we are talking about area. So how we define area? Area into length into breadth. If I take a rectangle, this is the length and this is the breadth. Okay. Length and breadth are those, both are actually both are actually represent a length. So that's why we have gone length and length square. So it's how we get the unit of area by multiplying two similar fundamental quantities. And what are those fundamental quantities? Length. Similarly, if I see the speed, how we define speed? Speed is defined as distance by time, and distance is nothing but length and time is time. So it's a derived quantity that we get from two different physical quantity, length and time. Thus, unit for derived quantities are called derived units. So definition of basic and supplementary units of SI. So normally in SI unit, the unit of length is meter. How we define meter? The meter is the length of the path traveled by light in vacuum during a time interval 1 by 299,792,458 of a second. Actually, before this, there is a particular 1 meter length stick is preserved in a museum, in a European museum, and that is taken as a standard 1 meter. But as we know, that is the old method, because we know that whatever metal, that is a alloy metal, that stick is made of alloy metal, and we know that anything if it get heated, it expand, and if it become colder, it compressed. Okay, so the length of that meter stick is not constant throughout the season, and for that reason, maybe let us say there is a particular story about that. So a people in England, two people in England, and they have gone to the king. One person is buying land from another person. The person who is buying land, he is saying that uh, he had buy a land, let us say 20 foot by into 20 foot. Okay, he has buy that land. According to him, the land is 20 foot into 20 foot, and the person who is selling the land, he is saying no, it is 25 foot into 25, and he's demanding the money for this much, and the person who is buying the land, he's wants to give money for this land. And both of them are true, they have measured their length, and they have shown they have also a 1 foot stick. Okay, both of them have 1 foot stick, but the length of that their stick are different from each other. So one person is saying that my stick is the correct one, other person is saying that my stick is the correct one. Now they have a dispute, so one is believing no one, so they have gone to the king of England. Now king said that okay, I have heard your plea, Let me ask my butler to bring the 1 foot stick. And do you know how this 1 foot came into being? My great great grandfather have taken a 1 foot, and the length of his foot is taken as a 1 foot length. So we have that stick in the treasury. So he sent his butler to collect that stick from the treasury so that he can compare whose stick is correct one. So the butler went to the treasury, but after some time he returned back without any stick and informed the king that treasury has been robbed. Somehow that stick is missing. And here is the story. So how can king know whose stick is correct one? So similarly, that thing may happen to us, right? We are taking certain length as a standard. Now that stick is lost somehow. How can I taking that standard? So scientists later think about that, and they think that we have to take something standard that can never be stolen, and speed of light can never be stolen. So that's why we have taken 1 meter as a 1 by 299792458 of a second. Actually this is the speed of light, okay, meter per second. Speed of light, actually we take c is equal to 3 into 10 to the power 8 meter per second. This is actually approximate value. The actual value is this one. So light travel in 1 second. How much a light travel in 1 second? That is taken as a 1 meter. Sorry, I am saying the wrong thing. Uh, Light travel this much distance in 1 second. So 1 meter travel in 1 by 3 into 10 to the power 8. So this much time in this second light travel 1 meter. So that's what is taken here. Okay, 1 by actually speed of light, 1 by c, or 1 meter equal to 1 by c, or speed of light 1 by speed of light second. Okay, this much second, how much distance a light cover, that is the length is taken as 1 meter. Now kilometer, a kilogram. The kilogram is the mass of an platinum iridium prototype which was approved by Conference Generale des Poids et Mesures held in Paris in 1889 and kept the Bureau International des Poids et Mesures. Okay, science seconds. The second is duration 9192631770 periods of the radiation corresponding to the transition between the two hyperfine levels of a ground state of cesium 133 atom. Ampere. The ampere is the intensity of a constant current which, if maintained in two straight parallel conductor of infinite length of negligible circular cross section and placed 1 meter apart in vacuum, would produce between these conductor a force equal to 2 into 10 to the power minus 7 Newton per meter of length. Kelvin is the fraction 1 by 273.16 of the thermodynamic temperature of the triple point of water. Okay, candela The candela is the luminous intensity is given direction of a source that emit monochromatic radiation frequency 540 into 10 to the power 12 hertz, and that has a radiant intensity in that direction of 1 by 683 watt per steradian. Okay. Mole, the mole is the amount of substance of a system which contain as many elementary entities as there are atoms in 0.012 kilogram or 12 gram of carbon for 12. And supplementary units, radian, it is supplementary unit of plane angle. It is the plane angle subtended at the center of a circle by an arc of the circle equal to the radius of the circle. It is denoted by theta. Theta is equal to L by R. L is the length of the arc, R is the radius of the circle. Steradian, it is a supplementary unit of solid angle. It is the angle between angle subtended at the center of a sphere by surface area of the sphere having magnitude equal to the square of the radius of the sphere. It is denoted by omega. If I take omega for a closed surface, the value always give 4 pi.